This is SpaceTime Series 29, Episode 63, for broadcast on the 27th of May, 2026. Coming up on SpaceTime, questioning the existence of the ice moon Europa's vapor plumes. A new study raises the questions of whether Earth's co-orbitals are stray asteroids or chunks of the moon. And Europe's SMILE spacecraft is launched on a mission to study Earth's shield against the solar wind. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study of Jupiter's ice moon Europa is casting doubt on previous evidence showing possible vapor plumes ejecting into space. The findings, reported in the journal Astronomy and Astrophysics, could have serious implications for the American and European missions now on their way to the Jovian system. Looking back at some 14 years of Hubble telescope data for Jupiter's moon Europa has given scientists a better understanding of its tenuous atmosphere. But it's also casting doubt on the idea that the ice moon's intermittently discharging faint water plumes into space from its global subsurface ocean. One of the study's authors, Kurt Rutherford from the Southwest Research Institute in San Antonio, Texas, says the evidence for water vapor plumes on Europa isn't as strong as first thought. Rutherford was one of the authors on the original 2014 paper which proposed the presence of the ice plumes, and he's now reanalyzed the data. His new paper has looked at some 14 years of data from the Hubble Space Telescope's imaging spectrograph, focusing on Europa's Lyman alpha emissions. Lyman alpha is a specific wavelength of ultraviolet light emitted and scattered by hydrogen atoms. Rutherford says between 2012 and 2014, the team were pushing the limits on Hubble telescope capabilities. One of the difficulties in interpreting the data back then was determining exactly where to place Europa within its context. See, the way Hubble works left some uncertainty in terms of placement relative to the centre of the image. And if Europa's placement was off even by just a pixel or two, it would have an effect on how the data gets interpreted. It means that what they originally thought could be evidence of water vapour plumes could also be static noise instead. The reanalysis has taken the original 99.9% confidence in the plume's existence and reduced it down to less than 90% confidence. Now that's still pretty good, but it's simply not good enough evidence to support the certainty of the claims being made at the time. Rutherford says the current dataset doesn't rule out the possibility of the water plumes first described in the 2014 paper, but it no longer provides concrete evidence for them. The new analysis also provides improved information about the neutral hydrogen atom component of Europa's escaping atmosphere, originating from its water ice surface. Scientists still hope to find water vapour plumes escaping from Europa. You see, similar water vapour plumes have been confirmed on Saturn's ice moon Enceladus, which also has a global subsurface ocean. And Europa's neighbour Io, another moon of Jupiter, has plumes of sulfur dioxide expanding out into space through volcanic eruptions. Cracks in Europa's icy shell could provide potential pathways for liquid water to rise to the surface and then shoot off out into space. And that's important because it would provide an opportunity for NASA's Europa Clipper mission to study the plumes when it arrives in the Jovian system in 2030 and when the European Space Agency's Jupiter Icy Moons Explorer or JUICE mission arrives in the Jovian system the following year. This is SpaceTime. Still to come, are Earth's co-orbitals stray asteroids or chunks of the moon? And the SMILE mission launches on its mission to study Earth's protective shield against the solar wind. All that and more still to come on SpaceTime. As well as our moon, planet Earth also has a group of asteroids orbiting around the Sun with it. Known as co-orbitals, these small bodies, sometimes called extra moons, are caught up in resonance with the Earth and end up staying around for hours, months or even years before moving off again. Astronomers have long believed that these co-orbitals wander in from the main asteroid belt between Mars and Jupiter. However, a new report in the journal Icarus claims spectral analysis shows that one of these objects, the 24 by 107 metre wide asteroid 469219 Camoalia, has a similar compositional profile to space-weathered lunar silicates that make up the Moon's surface regolith. And that's led some astronomers to suggest that Camoalia may in fact be lunar ejecta, debris created during an asteroid impact on the Moon, possibly the same event that created the 22-kilometre wide Giordano Bruno crater. To test their hypothesis, the authors used supercomputer models to simulate 12,000 possible impact events to see what would happen to this material over millions of years. They found that 70 of these 12,000 simulations could produce stabilised co-orbital objects larger than 10 metres in size. Now, that suggests that most of Earth's co-orbitals were more likely to have originated from the main asteroid belt. But it also means around 4.3% could have originated from the Moon. China's Tianwen-2 spacecraft is currently on its way to study the asteroid on what will be a sample return mission. It'll arrive there next year and collect around 1 kilogram of regolith from the asteroid's surface for return to Earth for more detailed examination and testing. What that sample analysis finds will have a significant impact on science's understanding of orbital mechanics. Now, if the sample is from the main asteroid belt, scientists will need to explain its strange spectral signature. But if the sample turns out to be from the Moon, scientists will be forced to rethink their understanding of the physics of lunar impact mechanics, crater scaling laws, and a range of other characteristics of the Moon. So whatever happens, it'll make for interesting times. This is SpaceTime. Still to come, the European Space Agency's SMILE mission launches on a mission to study the Earth's magnetic shield protecting our planet from the solar wind. And later in the science report, geologists say a new tectonic plate boundary could be forming in Zambia. All that and more still to come on SpaceTime. The European Space Agency has successfully launched its SMILE spacecraft on an ambitious mission to better understand the interaction between Earth's protective magnetosphere and the constant stream of charged particles flowing out from the Sun and the solar wind and space weather events such as solar and geomagnetic storms. The solar wind can damage anything in its path, especially when it builds up into solar storms. It can erode away a planet's atmosphere and irradiate its surface, destroying life. Our near neighbour, the red planet Mars, is a great example. The Solar Wind Magnetosphere Ionosphere Link Explorer, or SMILE spacecraft, was launched aboard a Vega C rocket from the European Space Agency's Kourou spaceport in French Guiana. Following launch and separation from the rocket, the first signals from SMILE were received by ESA's New Norcia ground station in Australia. The spacecraft's solar panels then deployed, powering its systems and science instruments. SMILE is a collaboration between the European Space Agency and the Chinese Academy of Sciences. It builds on previous spacecraft, including the Cluster mission and the XMM Newton Earth-orbiting X-ray telescope. Its 3-year primary mission will study how Earth responds to the streams of particles and bursts of radiation from the Sun using an X-ray camera to make the first X-ray observations of Earth's magnetic shield and an ultraviolet camera to watch the resulting northern lights non-stop for 45 hours at a time. This will allow astronomers to push the boundaries of science in an effort to answer some of the big questions which have remained a mystery for more than 70 years, since scientists first discovered that planet Earth sits within the gigantic bubble of the magnetosphere. And this interaction triggers disturbances ranging from minor substorms to major geomagnetic events, which can ripple through the magnetosphere towards the North and South poles. There, the magnetic storms set off the spectacular northern and southern lights, the aurora borealis and aurora australis. By comparing the X-ray and ultraviolet images, astronomers will read in real time the story of how Earth responds to the solar wind onslaught. During the next month, SMILE will slowly lift its orbital altitude through a series of 11 engine burns, ultimately ending up in an extremely elliptical orbit that takes it from 121,000 kilometres above the North Pole, where it collects data, before descending down to just 5,000 kilometres above the South Pole, where it delivers that data back to scientists on the Earth. The data collection will begin in earnest in July, after mission managers unfold the spacecraft's booms and open its camera covers and confirm that everything's working as expected. This report on Smile from ESA TV.
Every day, Earth faces a relentless attack from the Sun. A usually steady rain of tiny but fierce particles, known as the solar wind, can sometimes be interrupted by much bigger blasts. Luckily, we have a defence: Earth's magnetic field. This shield that Earth holds up against the solar wind is all that prevents our thriving planet from turning into a barren wasteland. And finally, we've reached a moment in history where our scientific tools and technologies are advanced enough to get to the bottom of how exactly this magnetic shield works. Our latest investigator? SMILE. SMILE is equipped with a unique toolkit to give us our first complete look at the interaction between the solar wind and Earth. It will be the first ever mission to look at the edge of Earth's magnetic field with X-ray vision to uncover where and how our shield is hit. At the same time, it will use ultraviolet vision to record the northern lights for more than 40 hours at a time, helping us understand how exactly Earth responds to solar storms. SMILE will send the data it collects back down to Earth, mainly to a ground station in O'Higgins, Antarctica. Scientists will dig deep into this data to find out more. They will tackle big questions, like what happens where the solar wind meets Earth's magnetic shield? What causes magnetic glitches on the dark side of Earth? And how can we predict the most dangerous threats in advance?
This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown that high blood pressure now affects 2 in every 5 Australians aged 18 and over. The findings by the Australian Institute of Health and Welfare determined that some 39% or 7.2 million Australian adults now suffer from hypertension. The study also found that almost 2 in 3 Australian adults at 63% with hypertension did not self-report the condition, and that indicates they may be unaware that they have a problem. Geologists say a new tectonic plate boundary could be forming in Zambia. The findings, reported in the journal Frontiers in Earth Science, provides more evidence supporting the idea that the African continent is beginning to break up. The authors have found hot thermal springs running through the Kalfour Rift in Central Africa, which is part of a 2,500-kilometre stretch of rifts through the continent. The authors investigated the makeup of gases in these hot springs, finding the levels of helium were comparable to the more established East African rift system, which we already know is in the process of splitting Africa into 2 separate continents, and in that process creating a new ocean. The authors say the gas levels indicate that this newly discovered rift has broken through Earth's crust and into the mantle. While this rift is expected to lead to the breakup of sub-Saharan Africa from the rest of the continent, the authors say in the meantime it could provide economic benefits for the region as it provides access to geothermal energy, helium and hydrogen. A new study has found that teenagers spend almost an hour on their phones between 10 p.m. and 6 a.m. on school nights, a time when they should be sleeping. The findings, reported in the Journal of the American Medical Association, looked at smartphone usage over this 8-hour window because a bedtime of 10 p.m. would allow the maximum amount of recommended sleep before needing to wake up at 6 a.m. to start the new school day. The authors found that teens spend an average of 50 minutes on their phone during this time, with more than 65% of that time spent on social media apps. More big news in the tech world this week, with Google's I/O 2026 Developers Conference in California announcing a series of updates for its Gemini app with new features including a daily brief, a redesigned interface, access to a new AI video model called Gemini Omni, and a new personal AI agent called Gemini Spark. The changes signal Google's push to turn its Gemini app into an all-purpose AI hub rather than just a standalone chatbot, making it more competitive with ChatGPT and Claude. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, they had their big Google I/O conference and they had a bunch of major AI announcements. As you can imagine, search has been changed. No more do you have the Henry links. We're going to have that for quite a while. So we have the Gemini AI overviews. to be able to more easily ask questions of Google via this AI mode. They're sort of expanding that, but also they've got this new mode that allows you to actually have these little apps they've created to help you. You might have some sort of guidebook for recipes. You can actually get Google to explain stuff to you. There's also information agents in search. These are personalized little AI agents that you can set up to work in the background to find what you need when it happens and that information is brought to you. So instead of you searching for things, you are now looking through things that are brought to your attention that you've curated to have brought to you. So no more are you sort of searching, but you're actually now looking through things that the system has found for you. On this agentic search, the search has been totally redesigned. I mean, they've got this new, if you use Gemini, for example, you have this new interface in the Gemini AI agent. But you can also now ask YouTube. There's a lot of great videos on YouTube, but you don't necessarily know where to start. You can search. But Ask YouTube entirely reimagines the experience. And you'll see videos that best match your interest, and it jumps right to the part of the video that's most relevant to you. And look, I've already done that sort of thing with search where it just takes you straight to the part of the video you want to see. But it's all been refreshed. It's all looking much nicer. Gemini Spark is this personal AI agent in the Gemini app that can take actions on your behalf and under your direction. And even if your phone is turned off or you turn the phone, this thing keeps working in the background. So we're getting AI to do things for us. Gemini Omni this can generate samples in any type of output from any type of input. So you might have a little slip of a video that is made, and it can extend that, it can add things in, it can change the background, it can be text and voice and video. It's sort of this next level of AI that we've been talking about for months and years now.
That's Alex Zaharov-Reutt from TechAdvice.life. And this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.